What up, athletes? All right, we're going to get here and talk a little bit about triangles. Most of this is stuff you've heard or seen in some fashion, but let's make sure we hit it all. So just looking at the assignment, your first question is going to have something similar to this, where we have these two figures, and we're told they're congruent. If they're congruent, it means they're exact in every way. But looking at this, clearly they're reflections of each other, right? But we see, for example, one arc right here means that angle A is congruent to angle Z. Boom! And I should probably use capital letters because they're using capital letters. And then we go down. What is angle B congruent to? Well, it has two arcs, so two arcs are on angle Y. Why? Because we love you. And again, angle C has three arcs on it, so does angle X, so that would be angle X. Do you see how we can use the markings to denote the congruency? And then we want to say, all right, so for B, so side AB. We see side AB goes from the 1 to the 2 arc, so going from the 1 to the 2 arc is side ZY. And order does matter in terms of this, so keep that in mind. You can't just throw in a random order. For AC, let's see, AC goes from the 1 arc angle to the 3 arc angle. So we're going to go from the 1 to the 3, which is ZX. ZX. And then last is BC. We see BC is going from the 2 to the 3, so we're going to go from the 2 to the 3, which is YX. Again, keeping in mind that if they're capital, we're going to use capital, and we're going to use the same order, going from the right angle to the right angle. Which means we have to name this carefully. We're going to do triangle ABC, or ACB means we're going from 1 to 3 to 2. So I'm going to go from 1 to 3 to 2, which is ZXY, triangle ZXY. Order matters when you're naming. Let's check that bad boy out, see how we did. Yay, we got it right. Awesome. So just keep that in mind as you're working these through. Order matters, capitals matter, good stuff. Right here, guys, now we're talking about, remember when we talked about translation, reflection, and rotation a couple of weeks ago? Well, what does it look like is happening here? And I can kind of use some tools to help draw there. It looks like if we were to draw a line right down the middle, it mirrored itself. Now, clearly my line's not great. Clearly. But that would clearly be a reflection. This one, the shape hasn't changed at all. It's like we moved to the right. Which one of these is a move? That's a translation. Now this one, it's like, I'll use my phone here, right? It's like we took it and we rotated it. Oh, we used the word rotation. And last one, just looking at this one right here, again, looks very similar to the second translation, so we're just going to translate it to the right. So just want to make sure and go over our little ways to manipulate shapes in geometry. All right. Sorry if you noticed a little blip right there. There was a morning announcement and I had to pause during that. But here we are. Okay, so for the triangles below, use the tools to move the solid triangle exactly onto the dashed one. Then answer the parts below. So let me see. I'm going to use my rotational tool because this looks like I need to rotate it some. Oh, now it looks like I need to flip it. Oh, there we go. Oh, now I got to move it. And then if I move it close to on it, I bet I can rotate it and finish it the rest of the way. Boom, look, it does rotate exactly on it. So these triangles are congruent. We see that. Now we're going to answer some questions about it and try to match it up. And you can see right here, I've already gone through a few of these. Angle W, right here where the long matches right here, we have angle D. Right there where the long matches the short. Where we have, right here, angle X is right where, angle X is right here. It's kind of where the two longer legs meet, so that'd be angle E. And then, where we have angle Y, is where kind of the short and the medium-sized leg meet. We have short and medium-sized leg would be angle C. There we go. Boom. Going down here. I'll click these all in, none of these. WX, sorry, I meant to have that. So we have WX. Well, let's look at that. WX is along the long leg. The long leg over here is going to be DE or ED. Let's see if we have that. Look, we have DE. Perfect. Now we have XY. XY is along the medium leg. So we're going to have what? CE or EC? CE right there. Boom. And then again, the last one is WY. Pardon that blip again. Another announcement. All right. So what we're working on, WY. So looking at WY, it's the short leg. So we're looking at what? CD or DC? CD. There we go. Boom. And then what do we have right here? Are all three corresponding angles and all three pairs of angles corresponding sides congruent? Yes, the triangles are congruent. Let's check it. How do we do? Correct. Boom, right there. Awesome. We got it going on. And then let's take a look at 4. This one's exciting. I like this one. We're going to actually do some math on this one. We're going to use what we know. So we talked about this a couple days ago, where if we have sides that are the same, what kind of triangle is this? It's isosceles. And if it's an isosceles triangle, we know something about their angles. I know that angle S and angle Q are going to be the same. So how can I use that for myself? Well, I know all three angles of a triangle add up to 180, so I'm going to take 110 or 180 minus 110. Almost had that wrong. And when I do that, I get 70. So I know these two angles add up to 70 degrees, but since they're the same, I also know if I take 70 and divide it in half, I'm going to get 35, and each of those angles are 35 degrees. So the measure of angle Q, I know right now is going to be 35 degrees. All right, this one right here, you may be thinking, what do we do? There's no measurements at all. No, but all three sides are the same, which means it's what kind of triangle? It's equilateral. And again, what do we know about equilateral triangles? We know that their angles are also equal. No matter how big the sides are, if they're all the same size, all their angles are equal. All the angles of a triangle add up to 180. And if all three angles are the same, I can just divide 180 by 3, which means the angles of an equilateral triangle will always be 60 degrees. Boom, right there. Let's put that in. So M is going to be 60. Is that all the question's asking? Yeah. And the last one we're going to go through today for this lesson is one that requires just a little bit more problem solving. And I want to talk to you about it because one like this can look a little challenging, but as long as you know what you know, it's not that bad. So again, let's focus on just this part of the triangle, okay? Looking at that, we see that it's isosceles because that leg matches that leg, right? Which means if this is 37 degrees, we know this angle is 37 degrees. And what can I do with that? Well, I know all three angles of the triangle add up to what? Add up to 180. And so I'm going to subtract, what, 37 times 2? Or 37 plus 37, which is 74. So now I want to do 180 minus 74. Get that final angle there, which is going to be 106. So I know right here, I have a 106 degree angle. It's obtuse. You know what else I know? I love knowing things. I know that this angle is supplementary to that angle. Those are a linear pair. So that means they also add up to 180. And that tells me, we talked about this the other day, if you have a triangle, an angle right here, this angle is equal to the addition of these two angles, the two opposite angles. How about that? It just is. It's a property. So I also know, just looking at this, this is going to be 74 degrees. But I know that's true also because 74 plus 106 is 180. So let's write that in. It's going to be 74. Now, let's focus on a different triangle. If I look right at this one, this small triangle, what else do we know about it? We know this side is equal to this side, which means they're isosceles, correct? So if this angle is 74 degrees, I know the angle on the right is also 74 degrees. Those two add up to what? 148? Which means if all three angles of a triangle add up to 180, 180 minus 148 is equal to what? 32? Boom. So angle X equals 32 degrees. I love these type of geometry problems. They're nice little problem-solving things, kind of a little game inside a game. So this was a good exercise, 32 degrees. I'm about to erase this, so pause it if you need to. Going, going, gone. 32, let's check it. Check the math, make sure we did it right. I do it wrong sometimes. Hey, look at that. So without further ado, you got one more problem. It's going to be a little more challenging. Check that out too. And as always, peace out. No, I don't know why I do that. I just started doing it.